We're looking at another SAT type geometry question, or just a challenge you could give to your geometry students. This is February 16th, 2014, doing a series of these quick screencast video tutorials for math educators and students. This is a fairly typical diagram we have here. AD is an angle bisector, and the 30-degree angle means we're looking at 30, 60, 90 triangles, and this is a review of those relationships that students need to learn well and to apply on many standardized tests. And unlike a regular standardized test question, we could ask students to find the lengths of all the other segments in the diagram. One approach is to start with the triangle on the left, the small triangle here, and this whole angle is 60 degrees from the big 30, 60, 90, so each of these would be 30 degrees, and then I copied the triangle down here, and using our relationships in a 30, 60, 90 triangle, we know the side opposite the 30 is 1/2 the hypotenuse. That is, the ratio between the shorter leg and the hypotenuse is 1 to 2. And then the longer leg is radical 3 times the shorter leg. So that would be the case here. We're doing well. Now we can move over to the large triangle. Big 30, 60, 90. We now know this is radical 3. So the hypotenuse would be 2 radical 3. Again, 1 to 2 relationship, 1 to 2 ratio between the shorter leg and the hypotenuse, and the longer leg, the side opposite to 60, would be the shorter leg times radical 3, which is 3. So we would end up then with all the parts we need. From the original diagram. So this would be 2. This would be radical 3. This would be 1. This would be 2. So the whole side would be 3, and this would be 2 radical 3. And some of the students would notice that this is an isosceles triangle, so we could have also mentioned that. Another reason why this would be 2. And finally, you can even show them an application of the angle bisector theorem, that the angle bisector divides the opposite side, this side, in the same ratio as the sides which include the angle which is being bisected. So just as this ratio, radical 3 to 2 radical 3, is a 1 to 2 ratio, we also see that the opposite side is divided into a 1 to 2 ratio. Thank you.